Hi everyone, this is WJ Tang, your physics and maths tutor. So today we're going to look at simple questions involving differentiations and how to solve it. So in this question, it mentions that given that x equals to t cubed plus 4 and y equals to 1 minus t plus 5t squared, part A of it asks us to find out what is dx dt, and part A2 asks us to find out what is dy dt. So we do know that if you want to differentiate the terms of x with respect with the terms of t here, according to some prior knowledge, if you are given the terms of y equivalent to ax power n, to differentiate y with respect with x, first, we'll first moving down the powers of x, which is n, by multiplying it, and then the remainings of it will write back, and the original power of n will reduce by 1. For example, if y is given as 2x cubed, dy dx of it will bring down the power of 3, multiplying it with 2x. Original power of 3, now reduced by 1, will give us 3 times 2 is 6, x of 3 minus 1, which is x squared. And that will be the basic of some differentiation. So in order to solve this question, we will ask to differentiate x with respect with the term t. So the solutions of it, part A1, we are about to find out what is dx dt. Differentiating the term of t cubed will give us 3t. Original power is 3, so now reduced to 2. Differentiating a constant such as 4 here will give us 0 since there's no term t inside it. And hence, dx dt will give us 3t squared. That's how easy it is, isn't it? Then let's take a look at another example of A2. We're asked to solve what is dy dt. And dy dt, this is the terms of y with in some terms of t. So again, similarly, we do it term by term. Differentiating 1 gives us 0 because it's a constant number. Differentiating negative t is actually your negative 1t. So that will give us just negative 1 because the t original power is 1 here. When we move down, multiplying with 1t, this power becomes 0. And so remaining will be just negative 1. The next term of it is 5t squared. So we bring down the power of 2, multiply with 5t. Original power of 2 now reduced by 1. So we'll have negative 1 plus with 2 times 5, which gives you 10, t to the power of 1. Or you can just write as negative 1 plus 10t. That's how we solve some basic differentiation question. On the next part itself, they ask us to find out what is dy dx in terms of t. So dy dx, in order to solve it in some other terms, such as t, let's take a look at what we had on the first part. We have dx dt. We have the term of dy dt. This means that we have to express our terms of dy dx in the form of dx dt and dy dt. And by prior knowledge of chain rule, it tells us that dy dx actually comes from a form like this. Is dy divided by some other term multiplied with some other term over dx, isn't it? And then in this case itself, since it's a term with respect to t, so it should be dy dt multiplied with dt dx. And so, to solve this question of part B, dy dx is equals to dy dt, which is the terms of negative 1 plus 10t, multiplied with the term of dt dx. But if you notice carefully, we only have dx dt. We don't have dt dx. So how to express dt dx in terms of dx dt? This again is another prior knowledge in which we know that this form of dt dx is actually equals to 1 over the terms of dx dt. Or in other words, is the reciprocal of the terms dx dt. And so we do the substitutions of here as 1 over the dx dt term, which is 3t squared. And hence from here, multiplying both of this together, we'll get the terms of dy dx, which is -1 plus 10t over 3t squared. And ta-da! Here we have our answer. I hope you benefit from these examples. And if you like to see more, please do like these videos and share it to your friends. Until next time, see you again. Bye-bye.